Hey folks, today we are working on negative exponents. Again, I know I've said this in the past few, but most of my videos are for 7th grade standards, but my advanced class gets into 8th grade standards, and this is another one of those 8th grade sections. So negative exponents, really, we don't want to work with them the way they are. Nobody likes those negative numbers anyway. So I'm going to teach you how to make them positive, and then everything goes back to what I showed you in the 2 videos that came before this, multiplying and dividing monomials, and then also powers of monomials. So here's what you need to remember. If an exponent's negative on the top of the fraction, move it to the bottom. If it's negative on the bottom of the fraction, move it to the top. If you don't see a fraction, then just stick a fraction bar and a 1 under it because it's always there. We just don't always write that. Oh, I need to write in red so you can see what I'm doing. So this 3 has a negative exponent on top of the fraction. So I'm going to move it to the bottom and make it 3 to the positive 2. I need something on the top, so I'm just going to stick a 1. 3 to the second is 9. So this is the same thing as 1/9. I've talked in my other exponent videos about the importance of leaving a negative number in parentheses if it starts in parentheses. So don't ignore those parentheses. Leave them there. This is really over 1. It's negative on the top, so I'm going to move the whole thing to the bottom and make, whoops, look what I did. When I wrote this, oh, you guys, I forgot to put my little negative there. Way to go, Luger. You're teaching negative exponents. I'm forgetting to write the negative exponent. For goodness sakes. Sorry. Okay, so that's going to become negative 2 to the positive 4. Stick a 1 on the top. And then you can go ahead and simplify or evaluate that further. Negative 2 times negative 2 times negative 2 times negative 2 is positive 16. Same thing with this one. If it's negative on the top, it's positive on the bottom. It doesn't change the sign of the number of the base. It only changes the sign on the exponent. So the negative 2 is still negative 2. The negative 4 is still negative 4. But the exponent becomes positive. Stick a 1 on the top so that you have a complete fraction. Negative 4 times negative 4 is positive 16, but positive 16 times negative 4 is negative 64. When you write that fraction, it doesn't matter if you put your negative sign on the bottom, on the top, or out to the side. One negative makes the whole thing negative. Okay, so taking it just one step further here, these all look a lot alike, but they have just enough differences that it affects how we solve them. This whole thing is really over 1. It's in parentheses, so the whole thing is going to travel in parentheses. If it was a negative exponent on top, it's a positive exponent on bottom. We need something on the top, so stick a 1 there to complete the fraction. Anything to the 1 is itself. So this is really just 1 over 5x. Let's look at number 5. Again, it's really over 1. It's in parentheses, so it's going to continue to travel in parentheses. So that whole thing goes down here, and we give it an exponent of positive 2. Put a 1 on the top. That way you have something there. Now, this is the powers of exponents that we talked about, or the powers of monomials. Each of these really has a 1, and you need to distribute exponent to exponent. So that's going to become 1 over 5 to the second, x to the second, which is really 1 over 25 x squared. Now, number 6 gets missed more than any other type of problem in this section. The issue is that 5 and x are not attached to each other with parentheses. So they are not actually together. They do their own thing. While the negative 2 is the exponent on the x, the 5 really has a 1 there. And he's positive. His exponent is fine. So the 5 is not going to move. The only part that needs to move is the x. We're going to put him on the bottom and make his exponent positive. So this is really 5 over x squared. You only move the portion or portions of the term with negative exponents. If the exponent's positive, it stays exactly where it is. Here's some more times where you've got to watch out for that. These look really messy and heinous, but we're just going to treat each part individually. If it's positive exponent, it stays. If it's a negative exponent, it moves, and then we'll simplify. So I go through first and I pick out anything that already has a positive exponent. I leave it exactly where it is. So on the top, a b is going to stay there. So I've already taken care of that one. And on the bottom, a to the fourth is going to stay there. So I've taken care of that one. I'm marking them out just to help myself see a little more clearly what I still need to take care of. So the a to the second, that's a negative exponent on top. I'm going to put him on the bottom and give him a positive exponent. Okay, I've taken care of that one. C to the negative third, I'm going to put that on the bottom and make it C to the positive third. B to the negative 1, I'm going to put it on top and make it B to the positive 1, or you really don't even have to write the 1. And C to the negative fifth, I'm going to put that on top and make it C to the positive fifth. Now I'm going to straighten this up a little bit. So on the top, put those B's together. I've got B to the second, C to the fifth. On the bottom, that would be A to the sixth, C to the third. When I did the video on multiplying and dividing monomials, I explained that I usually don't do for dividing where you keep the base and subtract the exponents, because sometimes, especially when you have negatives, you're going to have things that end up on the bottom, and that's okay. So I'm going to look at both of those variables separately, or all three of the variables separately. If I have more on top, it goes on top. If I have more on bottom, it goes on bottom. That b to the second, there are no other b's, so it's got to stay right where it is. A to the sixth, there are no other a's, so that's going to stay on the bottom right where it is. The c's, I have 5 on top and 3 on bottom, so I have more on top. If I ask myself how many more, the answer would be 2. So I have 2 extra on top, c to the second. So my final answer is b to the second, c to the second, over a to the sixth. Let's do another one like that. So I'm going to set up my fraction bar. Now this one, there's coefficients. I'm going to reduce the 12 and the 6. 12 over 6 is really just 2, so I'm going to put a 2 on the top. If you want to put a 1 on the bottom, you can, but you don't have to. So I'm going to mark those out. I've taken care of them. Let's see, the y to the fifth is going to stay on top because it was positive. And this x is going to stay on bottom because it was positive. The x to the negative third needs to go on the bottom and become x to the positive third. And the y to the negative second needs to go on top and become y to the positive second. Now let's clean it up. On the top, I really have 2y to the seventh. On the bottom, I have x to the fourth. I have no matching variables on top and bottom, so there's nothing that needs to cancel out or simplify anymore. That's as good as it gets. One more. Coefficients first, 4 over 6. If I just had the fraction 4/6, I would reduce that to 2/3. It's no different here just because it has variables beside it. Let's see. M to the third is going to stay right where it is. Here we'll kind of keep track of what we've done. M to the second is going to stay right where it is because those exponents were already positive. N to the negative 5, I'm going to move to the bottom and make it n to the positive 5. And into the negative 9, I'm going to move to the top and make it into the positive 9. Okay, so to simplify, the 2/3 is going to stay 2/3. On the m's, I have 1 extra on top, so that's just an m. And on the n's, I have 4 extra on top, so n to the fourth on top. That's as good as that one gets. This is kind of a tough section. So If that doesn't seem very clear, I would go back through, watch it again, maybe pause it before I go over the problems and see if after seeing it once, you can work them out on your own now and then hit play and check yourself. But as always, thank you for watching until the end of the video. I hope it did help you out some. If you need any more help with 7th or 8th grade math, go ahead and subscribe. I'm not in it for the subscribers, but if it helps you, please, that's what they're there for. If you need to contact me, there's my school email. Until next time, thanks so much. Bye.